While politicians fight over AI investments, scientists just achieved breakthroughs that will change medicine forever. CRISPR-GPT can design gene therapies in hours instead of weeks. Figure AI's robots are folding laundry and organizing groceries. Google's Gemini app just surpassed ChatGPT in downloads with offline capabilities. And here's the twist. Intel, the chip giant, is admitting they completely missed the AI boom. Today, we're diving into the practical AI revolution that's moving from labs to living rooms. Stanford Medicine just released something that could revolutionize genetic medicine forever. CRISPR-GPT, an AI tool that designs gene editing experiments with 95% accuracy in hours instead of weeks. This isn't incremental progress, it's a complete transformation of how we approach genetic diseases. Here's the breakthrough. Traditional CRISPR design required weeks of manual work to identify the right genetic targets and predict editing outcomes. CRISPR-GPT, trained on over 1 million genomic datasets, does this automatically using transformer architecture. The same AI foundation that powers ChatGPT, but focused on genetic sequences instead of human language. The results are staggering. When tested on 50 disease models, CRISPR-GPT achieved 30% higher editing success rates than human-designed experiments. It handles off-target effects using graph neural networks, addressing one of gene therapy's biggest safety concerns. Dr. Lei Qi, the lead researcher, calls this a leap for precision medicine, and the numbers support that claim. By reducing design time from weeks to hours and cutting costs by potentially 50%, CRISPR-GPT could democratize gene therapy access globally. The tool is open source, meaning biotech firms worldwide can customize it for rare diseases affecting small patient populations, conditions that were previously economically unviable to treat. This could enable cures for over 100 genetic disorders by 2030. But the ethical implications are massive. While CRISPR-GPT accelerates therapeutic development, it also makes genetic modification more accessible, raising concerns about germline editing and bioweapons development. The same tool that could cure genetic diseases could theoretically be misused for enhancement or harm. This represents AI's most profound impact on human health, not replacing doctors, but giving them superhuman precision in rewriting the code of life itself. While we debate AI's future impact on jobs, Figure AI just demonstrated robots that are already working alongside humans in practical everyday tasks. Their humanoid robots can now fold laundry, organize groceries, and perform complex manual labor with 90% task success rates in unstructured environments. This isn't the stiff, programmed robotics of the past. These robots, trained on 10 trillion data points using reinforcement learning, can adapt to new situations in real time. They stand 1.5 meters tall, can lift 20 kilograms, and most importantly, they learn from demonstration rather than explicit programming. CEO Brett Adcock frames this as robots as teammates, not replacements. BMW is already piloting these robots for factory use, where they work alongside human workers to handle repetitive tasks, while humans focus on complex problem-solving. The home applications are equally compelling. An aging population needs assistance with daily tasks that family members can't always provide. These robots could enable independent living for millions of elderly people worldwide. But the employment implications are complex. Rather than wholesale job replacement, Figure AI's approach suggests augmentation, robots handling the physical tasks that cause injury or burnout, while humans focus on interpersonal and creative work. Whether this creates more jobs than it eliminates remains to be seen. Google just achieved something many thought impossible. Their Gemini app overtook ChatGPT in App Store downloads, reaching 30 million users with a 45% growth rate. The secret weapon? Offline processing through their Nano Banana model. This represents a fundamental shift in AI accessibility. While ChatGPT requires constant internet connectivity, Gemini can process queries locally on your device across 70+ languages. This isn't just convenient. It's transformative for users in areas with poor connectivity and crucial for privacy-conscious applications. The competition between Google and OpenAI is driving rapid innovation. Gemini's offline capabilities, combined with seamless integration into Android devices, challenges OpenAI's early mover advantage in consumer AI. But the real winner is global accessibility. AI tools that work offline can serve billions of people in regions where internet connectivity is expensive or unreliable, truly democratizing access to artificial intelligence. Intel, the company that dominated computing for decades, just admitted they completely missed the AI revolution. Their Q3 revenue dropped 15%, with AI sales representing less than 10% of their business, while competitors like Nvidia capture massive market share. CEO Pat Gelsinger's confession was stark. We underestimated the ecosystem. Intel's focus on integrated manufacturing left them unprepared for the partnership-driven AI boom, where specialized chips from multiple vendors work together. This isn't just corporate misstep. It's a warning about how quickly technological leadership can shift. Intel is now restructuring 15% of their workforce and pivoting to a foundry model, but they're playing catch-up in a race they once could have led. The lesson extends beyond semiconductors. In AI development, agility and ecosystem thinking matter more than traditional manufacturing advantages. Here's AI's biggest contradiction. While consuming 2% of global electricity, AI systems are simultaneously optimizing power grids to save 15% through predictive algorithms. AI is both the problem and the solution to our energy challenges, using its own power consumption to make everything else more efficient. Not every AI deployment succeeds. San Mateo County spent $12 million on C3 AI's surveillance system over 3 years, expecting to turbocharge police investigations. The result? Less than 5% improvement in case closure rates. This failure highlights AI's reality gap, the difference between laboratory demonstrations and real-world implementation. Data silos, integration challenges, and overhyped capabilities led to wasted public funds and disappointed officials. The lesson is crucial. AI's theoretical capabilities don't automatically translate to practical benefits. Successful deployment requires careful integration, realistic expectations, and thorough testing before large-scale investment. AI's cultural impact accelerates as The Morning Show dedicates its new season to AI ethics in media, while fake AI memes of rock stars mourning Charlie Kirk went viral with 10 million views. Entertainment increasingly shapes public AI understanding, making accurate representation crucial for informed policy decisions. Today, news showed AI's transition from hype to practical reality. Criprs GPT proves AI can accelerate scientific discovery in ways that directly save lives. Figure AI's robots demonstrate physical AI moving into everyday environments. Gemini's offline success shows AI becoming truly accessible worldwide. But Intel's misstep and C3 AI's failure remind us that success isn't guaranteed. AI deployment requires more than advanced algorithms. It needs thoughtful integration, realistic expectations, and genuine problem-solving focus. The energy paradox captures AI's complexity perfectly. The same technology consuming massive electricity is optimizing power systems for greater efficiency. AI creates problems and solutions simultaneously, requiring nuanced rather than simplistic approaches. What emerges is a more mature AI landscape. The breakthrough applications, gene therapy design, practical robotics, offline processing, solve real problems for real people. The failures happen when organizations deploy AI for its own sake rather than addressing genuine needs. The medical applications show AI's highest potential. Criprs GPT could cure genetic diseases affecting millions while making treatments affordable globally. The robotics advances could enable independent living for aging populations while augmenting rather than replacing human workers. But the cultural impacts matter equally. As AI-generated content becomes indistinguishable from human creation, as shown by viral fake memes, society needs better AI literacy and detection tools. Entertainment's role in shaping public understanding becomes crucial for informed democratic decisions about AI governance. The practical AI revolution is here, happening in laboratories, factories, homes, and hospitals worldwide. Unlike the hype cycles of recent years, these applications solve tangible problems with measurable benefits. The question isn't whether AI will transform daily life, it already is. The question is whether we'll deploy it wisely. Success requires learning from both breakthroughs and failures, celebrating achievements like Criprs GPT while honestly assessing disappointments like C3 AI's surveillance system. The future belongs to those who can distinguish between AI's genuine capabilities and inflated promises. What practical AI applications do you think will have the biggest impact on your daily life? Are you more excited about medical breakthroughs, household robots, or something else entirely? Share your thoughts and subscribe for coverage that separates AI reality from AI hype.